Right, I'm going to go over an example of using linear interpolation when the data is given to the nearest unit. So we did this last lesson, and you use linear interpolation to estimate the mean, the median, the quartiles and the percentiles. The only difference really with this example is just the actual data. So we've got some pine cones which have been weighed to the nearest gram. So weight is a continuous measure, so that when you weigh something, it will take any value within a given range and there's no gaps in your data. But if you look at this table, there's gaps. So I'm going from 55 to 59, 60 to 63, 64 to 74, and so on. And this is because the pine cones have been weighed to the nearest gram. So it's possible they were weighed on some scales that just gave you the result to the nearest gram or something like that. So you need to just stop and think about what these class boundaries actually are. So the masses, which would round to the nearest gram, being between 55 and 59, would be that 54.5 is less than or equal to m is less than 59.5. And then once you get to 59.5, you would round up to 60. So this one is 59.5 less than or equal to m less than 63.5, etc. I won't write them all in. I've deliberately made the class widths different widths so that you can get an idea of what I'm doing. And so estimating the 10th percentile, we need to find 10% of the total number of pine cones. And to find the total number of pine cones, you add the frequencies, which gives you 50. So 10% of 50 is 10 over 100 times 50, which is equal to the fifth value. And so the 10th percentile, I've got 4 values here, and so I want to go 1 into the second class width. So I want to go 1 into there and work out where that fifth value lies. So it's the same method as we were doing yesterday. You do 1 over, or last lesson even, you do 1 over 11 times the class width, but the class width isn't 3, it's 4, because I'm going from 59.5 up to 63.5. So it's that fraction of the class width that we need to go in, and then you add that to the lower class boundary, which is 59.5, and that gives you 59.9 grams. So the method's exactly the same. It's an estimation because you're assuming the values are equally distributed through the classes. To find the 80th percentile, same method. So 80 over 100 times 50 gives you the 40th value. And so we just need to find whereabouts that is. So I've got 4 values here. Plus 11 is 15, plus 15 is 30, plus 4 is 34. So I need to go 6 into here. And there's 13 values in here. So it is 6 over 13. So it's that fraction of the class width. So that's 77.5. up to 82.5, which is 5. And then you add that onto the lower class boundary, which is 77.5. And that gives you 19.8 No, sorry, we're doing the wrong thing. 79.8 grams. So hopefully that makes sense. It's kind of common sense really, just using proportions. And then to find or estimate the 10th to 80th interpercentile range. This is just a bit like an interquartile range. So you just pick up the 79.8, take away 59.9, and that leaves you with 19.9 grams. I want to do one other question on this, which just takes it back the other way. I'll leave the table up and rub this off. Do pause the video if you need to, so you can copy stuff down. But I'll go ahead and rub this out. Hopefully that's not wet now. Right, so sorry, I'll just dry that off because it's going to be problematic. Right, so the second question is we can estimate the number of pine cones which weigh over 66 grams. This isn't data to the nearest unit now, it's just how many weigh more than 66 grams. So this is still linear interpolation, but it's just going back the other way because we want to find the number of pine cones now. So with this 66 grams, we're coming into here. And if you think about the class width, it's going from 63.5 up to 74.5. So the class width across here is 11 grams, and 66 grams is sitting here. And in this class boundary, there's 15 pine cones. So it's just taking it back the other way. The difference between 63.5 and 66 is 2.5 grams. So for this one, I need to look at doing 2.5 divided by 11, and it's that fraction of the 15 that we've gone in. So it's the same principle, it's just working back the other way. So if I do 2.5 over 11 times 15, that gives me 3.41. So sitting to the left of 66 grams, if they're all evenly spaced, there's going to be 3 pine cones. I was going to do it in a different colour. There'll be 3 there. And then sitting to the right of 66 grams, there's going to be 12, because we're between 3 and 4 here. And so the number above, so number weighing more than 66 grams will be equal to 12 plus 4 plus 13 plus 3. So 12 plus 4 plus 13 plus 3. And that gives you 32. So it's it's a little bit of a common sense sort of approach to this. So if you could work through exercise 2D, and this is on the sheet that I've printed out and left in the classroom. So exercise 2D questions, let's have a look. There's only 2 questions, questions 1 and 2. So the first one is data to the nearest unit and the second one isn't. So just check that with these questions. So if you could do both of those, and then I've left some consolidation work on binomial expansions for you to work through when you finish this. And then next lesson, we'll move into looking at standard deviation.